Mars. Most of what we know of Mars comes from the various spacecraft we have sent there. We have sent more spacecraft to Mars than any other planet. And as far as some of the highlights of missions to Mars, here we see Mariner. There were actually several Mariner spacecraft, but these were the first to fly past Mars and give us our close-up images of the surface of Mars. And we actually even have a feature on Mars named after this spacecraft, the Mariner Valley. Prior to sending spacecraft there, some people thought that there were canals on Mars. Well, the pictures came back and clearly showed that there were no canals, but Mariner did see a very long canal-like feature, and so it got named after this spacecraft. Up here we see Viking. Viking was in 1976, and this was our first lander on Mars. And there were actually two Viking landers and two orbiters. A part of the lander mission was to actually test the soil for life. And when we talk about life at the end of this presentation, we'll talk a little bit about the results of that. Not shown here, but there was, and these are just a handful of the missions. I'm kind of hitting some of the highlights. Mars Global Surveyor was in the 1990s, and some of the most spectacular images we have of the surface of Mars is a result of the Global Surveyor imagery. We've had now 3 missions that have had rovers. First one was Pathfinder, and that was in the 90s. Again, not shown here. Then there was Spirit and Opportunity in the early 2000s. Opportunity is still going. It's been running for about 10 years now and is not showing any signs of stopping. And shown here is our latest rover on Mars. This is Curiosity. Each one has gotten bigger. Pathfinder was about the size of a microwave oven. Spirit and Opportunity were about the size of a large desk. Curiosity is the size of a car. So they have gotten bigger, and each time they've gotten a little bit more autonomous. Pathfinder was restricted to being next to where it landed. The lander itself acted as a, what is the word I'm looking for? A relay station that actually sent the information back to Earth. Spirit and Opportunity were able to travel on their own around the planet and had a little autonomy as far as figuring out paths to follow, as opposed to Pathfinder, where we had to actually program the direct route it would take. Curiosity is even more autonomous, and you can pretty much tell it its end spot, and it will work out how to get there. In between all of these, we also had Mars Odyssey. That was in 2001 and was named after the film 2001: A Space Odyssey. Oops, no E-S at the end there. And so Y. Odyssey was looking for water. Water is one of the big things with Mars. We're interested in where is there water on Mars and where was there water on Mars. So between these and a bunch of others, we have studied this planet quite a bit. Now, on the surface of Mars, we tend to divide it up into two main regions. Now, in the picture here, I have it sideways, so I have a big white space to work with, but we actually have north to the left and south to the right here. And you notice very distinct characteristics. Through the middle here, this is more or less, if it'll draw, the equator going through the middle here. So you can see that the northern and southern hemispheres are quite different. In the southern hemisphere, we have a region called the highlands, and as the name implies, this is higher altitude, so highlands. And one of the first things you'll notice about the highlands is that it is heavily cratered. We can see, all of these crater features on here within the highlands. Now, the colors on this picture obviously are not true color. It is color-coded for altitude in this case, and so blue is lower altitude. As you get to red, it's higher altitude. Because there are more craters, we know that this part of the surface of Mars is older. Composition-wise, we're looking at silicates again. So like the rocks on Earth, like the surface of Mercury, the highlands are silicates. Also like the highlands on the moon. Our moon's highlands are silicate, they're heavily cratered, they're older, so very consistent there. Then we've got the northern hemisphere. And you can see here that it's colored blue, so that's low altitude, so that's called the lowlands. But what we're going to see is it is very similar to the Maria on our moon. So very few craters. As you can see in the image, there's some craters, but not a lot, not nearly as many as we see in the highlands. Fewer craters implies a younger surface, but again, always take young with a grain of salt in astronomy. So yeah, less than 500 million years old. And composition, this is mostly basalt. So again, like the Maria on the moon, also like our ocean floors, and also like the surface of Venus. And it is hypothesized that this was once an ocean. There's a lot of evidence building up to make us think that that is a likely scenario. For example, we see features that look like places where water might have been flowing into that lowland area. So we've got this channel looking like it heads in there. And so features like that make us think, oh, well, maybe that was a river flowing into the ocean. Now, we don't know for sure, obviously, but it is intriguing that we see these kinds of features there. Now, features that we do see on Mars, obviously craters. There's always craters. And as usual, the craters are due to impact. This is an image from the Mars Global Surveyor, this beautiful crater. And what you're seeing in the middle here, all this stuff that's rippled, those are sand dunes. So we see sand dunes in the bottom of a crater in this picture. Very, very pretty picture. Lava plains. Well, obviously there's basalt, and as we'll find, there's also volcanoes, but our lava plains are, obviously molten material from the interior, and here we're looking at places where it has flowed. It may have come out of a volcano, may have come from an impact, but one way or another it came from the interior. I mentioned volcanoes. Mars does have volcanoes, and those are hot spots, so we are not looking at plate tectonics. Again, we do not see evidence for plate tectonics, but we do have evidence for hot spots. And here we're looking down on top of 4 volcanoes. So we're looking down on top of the volcano here. Blue against blue is probably not a good idea. Here we go. So here we're seeing 4 volcanoes. You can see the calderas in the middle, the little hole, that's where the eruption occurs. This top one is called Olympus Mons, and it is the largest volcano in our solar system. It is about 3 times the height of Mount Everest, and if we were able to somehow remove it from Mars and bring it to Earth, it would cover the entire state of Florida. It is that large. Cracks and canyons, these are very much like the rift valleys on Venus. So we're looking again at kind of like the dry skin syndrome. It's cooling, it's cracking, it's splitting open. I had mentioned that the Mariner spacecraft has a feature named after it, and this is it, Mariner Valley. And this is a canyon system. You don't even see the whole thing. It continues off past the edge of the picture here. This is so long that if we put it in the United States, it would stretch coast to coast. Its width is about 100 miles. Comparing that to our Grand Canyon, the Grand Canyon would be a tiny crack on the edge of this canyon system. Water. Water is one of our key interests when it comes to Mars, and that's because we see these dried channels, these places where it looks like water has been flowing down this hill and cutting out these channels and then coming together and creating a little creek maybe flowing into a river. So we see things like this and say, okay, Mars had to have had water at some time. So where is it? That's a big question. If you were to go visit Mars, you would definitely want to dress warmly because conditions on Mars are quite cold. As you can see, it can get up to 60 degrees Fahrenheit, but that's unusual. This negative 150 degree low temperature is a lot more typical of the kinds of temperatures to expect on Mars. Picture here, all this white stuff. That is frozen carbon dioxide, which on Earth we call that dry ice. And so this is a typical winter scene on Mars with dry ice covering the surface. This is an image from one of the Viking landers. Another weather condition to be prepared for are global dust storms. So here, this is 2 Hubble images of Mars. And here we are in June. You can see the polar ice caps pretty easily. Lots of surface features are visible. So, just all sorts of detail in this image. And here we are in September, and we've got this dust storm going on, so that it is completely covering the entire planet. And you think about blowing dust, the kinds of winds necessary, and the kind of damage that can do, because essentially it's going to sandblast everything in its way. Dust devils. These are like little mini tornadoes, and they go swirling around on the surface and traveling along. This is an image from either Spirit or Opportunity. Dust devils have actually helped Spirit and Opportunity along the way because they will occasionally clean dust off of their solar panels, and that helps them to keep their power level up. Atmosphere of Mars is mostly carbon dioxide, and as we've seen before, this is from outgassing, mostly volcanoes. So we're looking at, again, evidence of volcanic activity on Mars, at least in the past. We don't know if it's still active or not. However, the atmosphere is not terribly dense. 1/100th of an atmosphere. Recall that on Earth, our atmospheric pressure is 1 atmosphere. So you're looking at an atmosphere 1/100th the density of our atmosphere. So here's a case where you need a pressure suit not to protect you from the crushing atmosphere like you need on Venus, but in this case to protect you from essentially exploding from the inside out from such low atmospheric pressures. Mars does have clouds. Here we are looking down onto Mars, so we're out in space looking down and we're seeing all these cloud features, and those are carbon dioxide rather than water vapor clouds as found on Earth. And it actually will snow on Mars, but the snow is going to be dry ice. So if you're in the mood for a snowscape on Mars, expect dry ice to come down. We talked about the channels. Well, in order for water to exist, water needs two things. It needs warm temperatures, needs to be above freezing. And we saw Mars gets as high as 60 degrees, and take that with a grain of salt because that is going to be kind of ground level on the warmest possible day. So your head will likely be quite cold even if your feet are warm because that thin atmosphere doesn't retain the heat as you go up higher. So you need above freezing temperatures. You also need a reasonably high atmospheric pressure. On Earth, if you live in very high altitudes, sometimes you have to adjust your cooking times because at low pressure, water boils more easily. It boils at a lower temperature. And so as the pressure gets lower and lower, the temperature to boil water gets lower and lower. So on Mars, if you were in that 60-degree sweet spot and you had a bowl of water, it would boil away because the pressure is too low. And yet, we see these features. Water was flowing on Mars at one time. And that's why we think the atmosphere has changed. We think that there had to have been a denser, higher pressure atmosphere in the past to maintain that water. And it had to have been warmer in the past to maintain that water. So the big question is, what happened? And we don't know. All we know is there is less atmosphere now than there used to be. It may partially be due to fewer volcano eruptions, so you are not replenishing the atmosphere. plus, of course, less carbon dioxide. It's going to retain less heat. The low gravity. Mars is much smaller than Earth, so the gravitational pull is less. So it is easier for atmospheric gases to escape. So did Mars once have a much more robust atmosphere that has changed to a very different atmosphere today? So if Mars had a thicker atmosphere, if it had what's what I'm looking for, a warmer temperature, more conducive temperature, could there have been life? Life needs water, and it needs the right conditions. Well, I had mentioned that the Viking lander had tested the soil for life. And here you see a scoop, and it deposited little bits of soil in various chambers on board, and it did different tests. So it looked for things like, the equivalent of breathing, or, like with plants, photosynthesis. So you're looking for a change in the atmosphere, or something like a metabolism. Did it eat? Were some nutrients ingested? Did something else come out? So those are the kinds of tests that they did, and they were partially successful. There were changes. Now the question was that because of life, or was it chemistry? Because chemical reactions can do those same kinds of things. So most people decided, no, not life, that it was a chemical reaction. In 1984, a meteorite was found with a very exciting name, ALH 84001. ALH stands for Allen Hills, which is a region in the Antarctic. It was 1984, and it was the first meteorite found there in 1984. They knew it was from Mars, and they knew that because of gases that were trapped inside exactly match the atmosphere of Mars. And then they cut it open and looked at it under a microscope, and they saw these little features. And these little features look like fossilized microbes. And so they analyzed them. And the composition is very consistent with life. But you also have people from the geology side saying it could just be geology. And no real consensus has been made concerning that. Is this a sign of life, or is this a sign of just geologic processes? So it's interesting that chemistry can mimic life, and geology can mimic life. And so then it begs a whole other question for biologists to answer. Where do you draw the line? Where does it stop being chemistry and starts being life? Or where does it stop being geology and starts being life? And that's a whole other can of worms. But Mars is interesting, and the potential for life on Mars is certainly one of the things that makes us so interested in that planet.